Hello everyone and welcome to class number second, and thank you for showing this patience because class has started 5 minutes late today. I usually consider myself as a punctual person, but sometimes in the rarest of rare cases things can happen here and there. So I apologize in advance and I can ensure it will not happen in future. Class will start exactly at 7 p.m. But anyways, this is class number second. If you have not watched previous class, please go and watch that. In the previous class we have discussed about the syllabus of this subject, and we have discussed the trends of this subject, how many questions you are going to find in prelims and how many questions you are going to find in the mains, and what is the significance of this subject in your selection. Apart from that, we have already discussed the sources that you must refer from NCERT to the notes and how we are going to proceed in the classroom itself. I'll be trying to give you a decent dictation in the class, but yeah, some of the things are going to be added in your PDF notes as well. So we have already discussed that. So if you have not watched previous class, please go and watch that class. Now, okay, so just let me give you a very quick revision for the students who were not present in the previous class. How we are going to go about in the future classes, what are going to be the modules of the subject. The first module that we are going to discuss today, and it is going to be energy. So that is going to be the first module. Today we will start nuclear energy, which is the part of the energy module. Here we have two parts. One is nuclear energy, second is non-nuclear energy. Today we will start nuclear energy. Second module, which is going to be after energy, it is going to be space. Again, very important module. There are a lot of questions in prelims and mains from this section, so we'll be focusing on that. Third module is going to be the biotechnology, IPR and health. Then we are going to cover IT, computer and artificial intelligence. Again, very hot topic, artificial intelligence. Even in last year, there was question from artificial intelligence. Then we will be focusing on defense, then nanotechnology, and there are going to be some miscellaneous topics. And one more thing that I would like to tell you is that in classrooms, I will be providing you a decent level of dictation depending upon the time that we are going to spend with. But yeah, there are going to be some points, some small topics here and there where I will not be providing you dictation. I will be just explaining in the class. The written part is going to be added in your notes. So that is going to be there. But it is going to be a combination of dictation plus your written PDF notes. But you still have a problem in those notes, you can always come to me and ask what are the doubts. Anyways, so what are going to be the cover, what we are going to cover in the nuclear energy that we are going to start today. In nuclear energy chapter, which is going to be starting just a few minutes ahead, so we'll be focusing on first basics of nuclear energy. Basics of nuclear energy, okay, in which we are going to talk about some like isotopes and the enrichment, what is the role of it, that we are going to discuss today. So that is going to be discussed today. Next is going to be nuclear cooperation agreement. That is going to be coming after basics. You know very well that in 2005, Manmohan ji, who used to be our prime minister at that point of time, he visited America, where we had one agreement with America, which is called 123 agreement, where America agreed to transfer civil nuclear technology to India, which is a very landmark agreement. Halanki, on the ground, this is not still implemented, but yeah, it is a very landmark agreement, not in terms of nuclear energy, but yes, in terms of America and India relationship that you already study in international relation also. Then we are going to go about the nuclear governance structure. Governance structure, you know very well, finance minister also already talked about in budget that we are going to spend around 25,000 crore on the nuclear energy because India has this target of achieving, the net zero by 2070, right? Which is our commitment to UNFCCC also. And India thinks that in order to achieve 20 net zero by 2070, if we invest today in the nuclear energy, because nuclear energy is considered as environment friendly energy. Apart from that, we have already passed Shanti Act in our parliament. Shanti Act is also going to be changing the whole scenario regarding governance of nuclear energy, because government is allowing developing nuclear power plants to the private sector also. So you see in future there are going to be private corporations entering into the nuclear energy, but yes, we cannot go free, free hand to the private sector. Till now, government, this nuclear sector was completely controlled by government because there were a lot of apprehensions regarding spreading of this technology here and there, proliferation of nuclear weapon technology. So that is why government had full control on this, technology. But now government feels that government agencies cannot go fully develop this because they are not able to have full potential of it, because we have lack of we have constraint of actually funding. So government thinks now that we must move to the private sector as well, but yes, there are going to be a lot of regulations. Okay, so that is going to be covered under government structure. We will discuss into full detail in class itself. Then we are going to have this nuclear power program, okay, that we are going to be discussing, because recently our prime minister Mr. Modi visited Kalpakkam, last to last year, Palkappam, and in Kalpakkam we have this free fast breeder reactor, and here he discussed few things that in future how we are going to go about it. So yes, nuclear power program that we are going to discuss. Then we are going to discuss nuclear weapon program of India, and that is also going to be very crucial. And we have in 1974 and in 1998 we had nuclear test which is done by India, which established India as a nuclear weapon power in the world. And what are the technologies that we used there, what is our doctrine, which is no first use doctrine that India adopted. So we will be discussing about that also. Recently there were some voices where people are demanding that India should change its no first use policy, so we'll be discussing that also. Otherwise I'll be little bit avoiding the political aspect of it, because that you study in other subjects, especially in polity and IR. But I'll be discussing some technical aspect of this as well, so that we will be discussing. Then we have this fusion power, okay, so that is going to be discussed. Right now India does not have that sort of program to implement the fusion power, but yes, China recently achieved a great success in the fusion power. China is able to achieve 120 million degree centigrade temperature using nuclear fusion power, which is definitely a game changer in this whole field. Even South Korea achieved something. South Korea also achieved 100 million degree centigrade temperature, maybe only for a few seconds, but yet yes, they have achieved. So hydrogen, if we are able to extract energy from the nuclear fusion using hydrogen, it is definitely going to be a game changer in terms of the climate change also, and the security, energy security as well. The sun and all the stars, they have this nuclear fusion energy. That is why they are able to emit immense amount of energy, and which is happening in our sun also. So we'll be discussing that, and then there are going to be some miscellaneous topics here and there. So this is how we are going to go about in the nuclear energy. And the first thing that we are going to discuss in today's lecture is going to be the basics of nuclear energy. Okay, and I hope you are comfortable in understanding my language, and I hope most of you understand little bit Hindi here and there. But yes, any of if any there is any one of you who doesn't understand Hindi at all, you can tell me in the chat box. Okay, so if I use 1-2% Hindi here and there, are you comfortable with that? Does everybody understand Hindi? Please tell me in the chat. Okay. Okay, so we have two students, they don't understand Hindi at all. Anyways, so you don't need to worry about it. Even in case if I use 1 or 2 sentences of Hindi here and there, so you don't need to worry about it, because I'll be translating that into English as well. And sometimes, Hindi is my first language, so I'll be using some cracking some jokes here and there, maybe in Hindi. So that is not going to impact your preparation at all. But still, I will be avoiding use of Hindi, but sometimes it can happen naturally. Okay, so today we'll be starting this basics of nuclear energy. Okay. Anyways, so let's start. Basics of nuclear energy. And the subject of this science attack, I assume that most of you are, it happens to me in Delhi. Most of students in class are basically either engineers or science students. But yes, this whole subject of science and tech can be little bit on the easier side for those students who actually studied physics or like chemistry in their schools, or later on in their engineering, so they might be finding it little bit easier. But the students who are from the humanities, I would honestly say that you need to basically work harder for this subject. And this subject can be a make or break subject for you in exam. There are going to be around 5 questions in your mains exam from the science and tech. And if you consider overlapping, so there can be more as well. Recently there was a question from artificial intelligence in GS paper 4 also. Yeah, so that can also happen. There was a question from science and in GS paper 1 as well, so that can also happen. But even from the GS paper 3 perspective, there are going to be 4 to 5 questions, and there are going to be 40 to 50 marks from this subject, which is going to be a deciding factor. Because like if there is a question from like IR, like there is a question from India Maldives relations, so everybody is going to write something from there, right? But if there is a question from science and tech, and if you don't know anything about it, so you will not be able to write anything. So in science and tech, you cannot like write for the sake of writing. Like, so either you know the answer, if you don't know the answer. So av- so you can say that 90% students are going to write anything about everything. But in science and tech, if you have understood this subject properly, and if you are able to write those 50 marks questions, and if you are able to secure decent marks there, so you can be basically ahead of other students who feel little bit discomfort in science and tech questions. So this is basically this is a subject which is going to an edge. So there is GS paper 4 which is going to give you an edge. X factor, it can be basically play an X factor. There is going to be essay, and there is going to be science and tech which can act as an X factor. If you strengthen this part of your syllabus, science and technology, so you can say you are already ahead of 80 to 90% students who feel little bit, discomfort in this subject. So please, even if you're from the engineering background, science background, or humanities background, okay, please focus on this subject. This subject is going to give you extra marks. It is going to secure your rank basically. Okay, so please don't underestimate the subject. And even here, if you have come here to prepare for UPSC, so you cannot say, oh, I don't like this subject, I will not be preparing it. No, you that choice you don't have basically. It's not a buffet that I will be covering all subjects which I find easy. That is not going to happen. You need to focus on each and every subject depending upon their requirement in the exam. You cannot ignore science and tech. Doesn't matter how difficult you find it, still you need to find a way to understand it, to be able to write an answer in it. And if you basically come to class every day, if you make decent notes, if you read your newspapers, okay, if you refer your notes properly, I can guarantee you that in the end of these classes, you will be comfortably writing decent answers in science and tech. Because during the class itself, I'll be telling you that this was the question which was asked in previous questions. So you will be able to understand the requirement of the answer. So this is going to happen. This is how classes are going to be there. So I don't want to scare you basically. I just want to tell you the reality here. Okay, even if you are for humanities or science or engineering background, doesn't matter. Even if you find science and tech difficult, which is actually a difficult subject, not easy to understand, you need to revise it multiple times. Still, you need to work harder, very hard to understand this subject. It's not easy. It's not as easy as IR or polity or history. Yeah? This is going to be little bit on the difficult side. And it's quite dynamic also because always there are some sort of some innovations here and there, so you need to update your knowledge all the time. But anyways, let's be very practical. But yes, I am here for you in case you have some doubts in every way. Anyways, so let's start the class basics. And students who are basically preparing for 2025 or 2026. So students who are preparing for 2026 or let's say 2027. So you don't think that you have much time, because time just flies, yeah. Time just flies. So you need to be on your toes all the time. So okay. So please pay your, you need to be very attentive in class. You need to go back and revise your notes and everything. Anyways, let's start it. Okay. So can we move forward? If you have any doubt, please ask here itself, because when class starts, it is going to be like, on fifth gear only. Okay. Okay. So can we move forward? Yes. Okay. Thank you. Okay. Okay. Thank you. Thank you. Okay. Great. Great. Okay. So we'll be starting with very, very basic information that you already know. In your school, you have already read about structure of atom. Okay. You already know it. You already know that in atom we have a nuclei. In nuclei we have proton, and in nuclei we have neutron. You already know this. Yes, on proton we have positive charge. On neutron we have no charge. And then we have electrons in the orbit. Electrons have negative charge that you already know. So I don't need to go into your classes again, your school. But yeah, I assume that this information that you already know. So we have a nucleus in which we have proton and neutron, and then we have outer orbits where we have electrons with negative charge. Now, in your school, you have already read about atomic number, a concept called atomic number. Atomic number. Do you remember we used to have a periodic table, है ना? And we used to find it very difficult to memorize the name of the elements in the periodic table. Do you remember that periodic table? It used to be something like this periodic table. I had a poster of periodic table in my home. Still, I was not able to memorize all of them. But yes, I was decent in memorizing around 70 of them. I forgot later on. That's a different case. But yes, atomic number. So atomic number, what is atomic number? Atomic number is basically a criteria to arrange elements in the periodic table. Let me write for you. It's a criteria. It's a criteria to arrange elements in periodic table. Okay, in periodic table. Atomic number. What is the meaning of atomic number? Atomic number simply means number of protons. It simply means number of protons. Atomic number. Okay. Humans have a very interesting this property characteristics of arranging things, categorizing things. We love categorizing things, and we categorize different animals, different plants, different sort of life, and even we categorize people on the basis of their nationality or even their features, everything basically. And so we categorize these elements also because in that way it is easy to read them, to do some research or to study them. So yes, atomic number simply means number of atoms. We have one more number, which is called atomic mass, or you can say mass number. Okay, let me add one more slide here. Mass number. Atomic mass or mass number. Now, what is the meaning of mass number? Mass number means neutron, which is in the nucleus, plus proton, which is also in the nucleus. Okay, so neutron plus proton is the mass number. Okay, there's no role of electron here. You need to remember it. If we consider the number of proton, it's called atomic number. And if we consider the number of neutron plus proton, it is called mass number or atomic mass. That we already know from your school days. One interesting concept that we are going to focus today is going to be isotope. So how many of you are from the science background or any other background, doesn't matter. Have you ever heard about this word called isotope? And if you have heard about it, what is the meaning of isotope? Please tell me in the chat. What is the meaning of isotope? Okay, I'm waiting for your answers. Okay. Very good, Kritika. Very good. Anant, very good. Very good. Vijay Lakshmi, great, great, great. Very good. Okay. Vijay, great, great. Rohan, great. Shilpa, great. Okay, 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 okay. Very good, very good. So I was not expecting actually that much of right answers, but I'm proud of you. You are only, you already know about it. Thanks. So what is the meaning of isotope? Isotope means when there is same atomic number, but different mass number or different atomic mass. Okay, isotope means same atomic number but different mass number or atomic mass. That is the meaning of isotope. Should I give you some examples? Yes, okay, great. Let me give an example of hydrogen. Hydrogen, the first element in our periodic table, very easy to understand. We already know that hydrogen has one proton. That is why this is first element in the periodic table. But it has different isotopes. Hydrogen has three isotopes. Three isotopes. First isotope that hydrogen have is called protium. Protium. Protium means it has one proton, zero neutron. So atomic number is going to be 1 and mass number is going to be 1. Let me write. This is atomic number and this is mass number. So one proton, zero neutron. That is protium. If protium reacts with oxygen, we get H2O, which is our water. Water that we use every day. That water that we drink, or you can call it light water. The water we drink. You know, on our earth, 99.98% water is this light water. This light water. Okay, this is your protium. Then second isotope that we have is deuterium. Deuterium, you must have heard about it before as well if you are reading newspapers and everything. Deuterium means one proton and one neutron. Okay, in protium we had no neutron, here we have one neutron. So if you add proton and neutron, mass number is going to be 2. Okay, one is atomic number, 2 is mass number or atomic mass. And if you add oxygen to it, you will get D2O. D2O. Okay, deuterium oxide. You get D2O, deuterium oxide. This is also called heavy water. This is not a regular use water. It's heavy water. And where we do is where do we use it? In nuclear reactors. In nuclear reactors, for the cooling purpose, we use this heavy water. Okay. Then the third isotope that we have is tritium. Tritium. T. So yes, one proton, but two neutrons. The proton plus neutron, mass number 3. This is called tritium. Okay. The one point that you must remember about tritium is it is radioactive. It is radioactive. It emits radiations. Sometimes you can call them beta radiations. Okay. This tritium is used for weapon. That hydrogen weapon you talk about. Okay. It's a weapon grade hydrogen isotope. You use it in nuclear fusion technology or making hydrogen bombs. Okay. Nuclear fusion can be used for making weapons or bomb, or it can be used to generate electricity. Okay, it is going to emit immense amount of heat. Now it depends upon the human being how we are going to use that heat. Are we using that heat to kill millions of people, or are we going to use that heat for producing electricity for the creative purpose or for the destructive purpose? It depends upon human beings, because technology itself is not judgmental. Technology itself is neither good nor bad. We make it good or bad the way we use it. Okay. Okay, nuclear fusion or nuclear fission, these are the two technologies that we have. Nuclear fission is also a nuclear energy that can be used to generate heat, and that heat can be used to kill people or to generate electricity. In our nuclear power plants, we use nuclear fission. And the bomb which was used on Hiroshima and Nagasaki by America in Second World War, the same nuclear fission technology was used there to kill millions of people. The technology itself is not good or bad. We make it good or bad. It's like these days we are using artificial intelligence. Some people might be using it for creating deep fake videos to spread their propaganda. That can be used there to spread misinformation, fake news, manipulate people. But there might be some people who are using same artificial intelligence to increase their productivity. So these are like, you know जिसको हिंदी में कहते हैं टू दो धारी तलवार, है ना? It's a double edged sword. It depends upon people, the collective consciousness of society, how we decide to use that technology. North Korea is using same technology to make nuclear weapons. South Korea is using to generate electricity and to power its cities and infrastructure. Okay, this is how things work. I hope now you have some idea about the isotopes. Hydrogen. Okay, let me give you another example of another isotope which is more important for our exam than hydrogen, is uranium. This is the core of this module, nuclear energy, uranium. Okay, atomic number of uranium is 92. It means number of protons are 92, but there are isotopes. Number of neutrons are different. So we have three isotopes of uranium. One is mass number 233. Okay. One is uranium with mass number 235. One is uranium mass number 238. Okay. These are the three isotopes. Easy, easy peasy lemon squeezy. So this 92 is atomic number. These are the mass number, or I mean proton plus neutron. If you want to find out the number of neutrons, you simply subtract. Simple. Simple math question. I hope that much of math you already know. What is a special thing about this? We have this habit of categorizing things. So we have categorized these isotopes as well. So uranium 233 and uranium 235, they are fissile isotopes. Fissile. Uranium 238 is fertile isotope. Fertile. Now, what is the difference? What is the difference? Let me just tell you in one sentence, then later on I'll be explaining you what is the meaning of that. You know, these are the radioactive elements. And what is the property of radioactive elements? Their property is that they diffuse, they emit radiations, they disintegrate continuously. Fissile means they themselves go through nuclear fission. Uranium 235, uranium 333 elements, they break into smaller elements. They disintegrate themselves. They have this nuclear fission naturally. They can go through nuclear fission themselves. They break themselves. Fertile means they don't break into themselves. They convert into some other element, and that element goes into nuclear fission. Okay, that is the meaning of it. Uranium 233, 233, 235, they go through nuclear fission directly, but uranium 238 goes into nuclear fission indirectly. It turns into something else, then it goes into nuclear fission. So there is a two-step process in fertile and one-step process in fissile. That is the difference. So they go through nuclear fission. Nuclear fission. What is the meaning of that? Let's take uranium 235. Then you strike it with a neutron. In order to break it, okay, you strike it with neutron. This uranium 235 is heavy. What is going to be happen? What is going to be the outcome of this hitting, this bombardment? Uranium 235, which is heavy nucleus, is going to break into two lighter ones, like barium or krypton. Later on we'll do about that. But apart from breaking into two lighter ones, it will generate lot of heat. Lot of heat. Okay. So uranium 235 will break into smaller ones along with heat. Now it depends upon you. What do you do with that heat? You make electricity or you make weapon? That depends on you. The chain reaction you must have heard in your schools or something, right? It will happen with the fissile elements. Fissile elements. So we have this fissile element. It has neutron and proton in the nucleus. When you hit this nucleus with a neutron, it will break into two lighter ones, let's say X and Y. Then further, it will release three neutron plus lots of heat. These three neutrons will further hit neighborhood with the nucleus which is in the neighborhood. It will again generate heat. Three new neutrons will be there. Okay, let me see if I have a picture of that. It's like chain reaction. Okay, it's like chain reaction. Okay, let's see. This is I'm talking about. So we have uranium 235. We are going to strike it with a neutron. Fusion reaction will start. It will break into barium or krypton, but yes, there is going to be immense amount of energy which is going to be released. These three neutrons which are released further are going to hit another nucleus. Same process will happen. Three new neutrons will be generated along with the heat, and this process will go on, go on, go on. This is called nuclear chain reaction. If it happens in a controlled way, we can control the heat. Okay? We can convert that heat into electricity, which is a usual phenomena in our nuclear thermal power plants. But if this heat is uncontrolled, it is used in atomic bombs. Simple. Okay? This is what is happening with the fissile elements, which is our 233 and 235. But what is going to happen with the fertile one, 238? Let me just tell you. So this is uranium, no, sorry, this is uranium 238, which is not fissile, it is fertile. You must remember that fact also. So if you hit it with a neutron, it will convert into another element. So it will not go directly into the chain reaction. No, no, no. First, it will transform itself into something else. Then that element will go in under fission. It will go under fission. This is how fertile elements basically react. Okay. And if you remember in your schools, you must have heard about that a neutron change its characteristics or kind of converts into proton plus electron. It's not a direct conversion. It's actually beta particle element radiations. This is how things happen. But for the sake of simplicity, which is mentioned in our school books also, you can say that neutron can transform into proton plus electron. Okay, rather than going too much into particle physics or something, just remember this fact for the sake of general studies only. If you have this inclination or curiosity to do research after selection, you can do that also. You can become nuclear scientist as well. But yes, for the sake of simplicity, just remember neutron can transform itself into proton plus electron. So what is going to happen this uranium 238, which is fertile? What is going to happen? So this is the nucleus. Okay, let me take it with the black color. So this is the nucleus. Okay, this is our atom. Now we are going to hit this with a neutron. It has atomic number 92, mass number 238. So it will not go directly into chain reaction the way it was happening with the uranium 235. No, 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 no. It will absorb this neutron. It will make its own. This neutron is going to be absorbed by the nucleus of 238. So, getting my point? This neutron is going to be absorbed by the nucleus. So, mass number is going to be changed. It will change into a new element 92 and 239. Looks this another element. This is the another element. Okay, this is the another element. This element will go under fission. Fission means when heavy nucleus break into smaller ones. That is the meaning of fission. So how it will break? It will emit radiations as a part of it process, like beta emissions. So it will emit. What it will emit? Two neutrons are going to be converted into two protons plus two electrons, which is going to be beta emission. Okay. So we have alpha, beta, gamma emissions. So I'll not be going into that much of physics, but yeah, you just remember it. Two neutrons now from this new element, two neutrons are going to be converted into two proton plus two electron. These are like the beta particles. These electrons are beta particles. Okay, beta particles. Beta particles. Not direct electron, but yes, you can call them beta electrons. They have negative charge, so we call them electrons also. That is explained in your school books. Okay. Now what will happen? If two neutrons are converted into two proton, two proton. So don't you think atomic number will change? Do you think so? Because if two neutrons are converted into two protons, atomic number will change. It was 92 earlier. Now it is going to be 94. Yes, it is going to be 94. Look, mass, let me just explain in the simplest way. Mass number was neutron plus proton. Now two neutrons are converting into two proton plus two electron. So mass number is going to be, so there is subtraction of two neutron. Yes, but there is addition of two proton. तो mass number is going to be same. 2 से 2 कट गया भाई, तो this is still going to be n plus p, right? So mass number is going to change, but because of the addition of two protons, atomic number will change. Yes, atomic number will change. So it was 92 uranium 239. It will convert into 92 uranium, like sorry, it was 238. Okay, it was 239. It is adding, getting one. Then what is going to happen? What is going to happen? It will, two neutrons will convert into two proton and electron. Let me plus it. Two neutron, okay, sorry, two proton plus two electron, okay. Two neutrons are going to be changed into that. Now what is going to happen? Two protons are added. Two protons are added. Two neutrons are subtracted. Yes, because two protons are added, so atomic number is going to change, but atomic mass will remain same. If two neutrons are gone, but two protons are also added, na? So total mass number does not change, but atomic number will change because now we have two protons. So now we have this. Do you know what it is called? It is called plutonium. It is called plutonium. It is going called plutonium. So what was the nature of fertile? For nature of fertile was it will convert into another element. So our uranium is converted into plutonium. And this another element will go under nuclear fission. So we converted uranium into plutonium. Okay? Uranium into plutonium. Remember? And this plutonium will go under nuclear fission. And you know what is the meaning of nuclear fission? It will convert into X and Y along with immense amount of heat. Now it depends on you. What do you do with that heat? Okay. Do we have this technology? Does India have this technology? Answer is yes. We have this. It is used to make nuclear weapon in India. Nuclear weapon in India. 1974, 1998, the test we have done in Pokhran, Indian nuclear weapons were based on plutonium. Okay? Will you remember this? You must remember it. I don't care you find it difficult or easy or interesting or something, but for the sake of examination, you must remember it. Okay? If you find any difficulty, ask me any question right now. Or go back to your home after the class, watch this section again, read your notes, okay? And if you are able to use chat gpt little bit here and there, if you are interested in that, you can do that as well, but please clear your doubts. For science background student, they may find it quite easy, but for the art student, I know there can be little bit difficulty, but you don't have any choice. You can't leave this section. It can be a make or break thing for you in your examination. Questions from science and tech, even in prelims, because in prelims it also happens many students think science and tech is quite difficult, so basically they don't focus much on this section. But the students who are well versed in science and tech questions, if they are able to handle 70% questions from science and tech in your prelims, they have definitely an edge of more than 20 questions, 20 marks. This section can be make or break, because this is the section where you get an edge, that X factor. Mostly students are going to ignore this section, so they will be giving more time to geography or history or polity and ignoring it. So please keep that thing in mind also, that it's as important as your history, as important as your geography, polity, economy. So don't underestimate it, because it is going to give you edge. And if you look at the toppers, and if you look at their answer sheets from GS paper 3, if you look at their answers from science and technology, it's not difficult to find out, yes, they have basically mastered their science and technology section. Yes, they have that extra factor, they have that an edge, that privilege of preparing science and technology in a proper way. So please keep that thing in mind also. Okay, आगे चलें, चलो बहुत बढ़िया. You must have heard about one more element which is very crucial for this discussion as well, and you must have heard about it, which is called thorium. Okay, thorium. Thorium. Atomic number is 90. Mass number is 232. But remember, for prelims, thorium is not fissile. Thorium is fertile. So you know very well, it itself is not going to go under fission. Okay, it needs to be converted into something else, another element that will go under fission. And you also know that India has largest reserves of thorium. There was already a question in exam from this section, that coastal sands in Kerala, Western Ghat, Tamil Nadu, Andhra, yes, India has the largest reserves of thorium. So in order to make this thorium useful, we have to convert into fissile element. Okay, because fertile itself cannot go into fission, we have to make it fission friendly. So we have to make it convert into fissile. And how do we that? By bombarding it with neutron. Okay, do that. So yes, we have thorium 232. We are going to strike it with the neutron. This neutron is going to be absorbed by the nucleus. Okay, it will become thorium 233. The same process which was happening earlier. Now it is fertile. It was fertile, now it will convert into fissile. Same process will happen. Two neutrons are going to be transferred or transformed into two proton plus two electron. Two protons are going to be changing into, they will change the new atomic number. Yes, they will change the atomic number. Now, what is going to be the outcome? 92 thorium 233. You know, mass number does not change, because two neutrons are subtracted but two protons are added. So mass number is still same, but atomic number will be added by 2. This is fissile. What do you mean by fissile? It will go under fission. Fission means it will convert into, let's say, X and Y, plus there is going to be immense amount of heat generated as an outcome of this process. This is how things work. And I hope you recognize it. What is it? It is uranium, right? So it is uranium. It is uranium. Uranium 233. Remember? Isotope uranium 233, 235, 238. So thorium in this process is converted in uranium. Wow. This is how things work. This is how things work. Now question might be, sir, if we have largest reserve of thorium, why don't we convert into uranium and use this uranium as a fuel in our nuclear power plants or as a nuclear weapon fuel? That might be a question in your mind. But there is a problem. One problem is that this process is extremely technologically extremely challenging. Extremely challenging. And we don't have that technology yet. Even you convert thorium into uranium, still we can't use this uranium 233 as a fuel. We don't have that technology. So even if you convert, we can't extract. Extraction is a problem again. If conversion is not a problem, extraction is a problem. That is there. So, first of all, we don't have that much of expertise. Why don't we have expertise? Because India spends very less on R&D. The government does not have capacity because government needs to spend on other things like freebies, food subsidy, fertilizer subsidy, other subsidies, lot of freebies there, right? So we don't have that much of money left for R&D, especially in the nuclear technology. So that is first problem. And you know what happens in our, we don't have like that level of human resource as well. Whatever human resource we have, the experts we have, they always, you know, migrate from India. They go to US or Japan or Singapore or some other countries to serve them because they don't have enough support here financially. So they leave us. So that is there. So that is why now government is actually thinking of, allowing corporates in this whole scenario because corporates have funds and they can, government is also encouraging them to spend in R&D so that they can, the part can participate in this whole nuclear scenario. So that is also there. But India may, corporates, even if they have money, they are not interested in these kind of R&D. They are more interested in, serving you food in 10 minutes. And they are more interested in logistic kind of stuff. They are just, kind of having some commission in between. So they are not interested in spending these, technologies because it's easy to make money on these platforms like these Flipkart or all these kind of delivery apps. By selling vegetables, you can earn money by the evening. But if you invest in these kind of technologies, they have a long gestation period. They can take 10 years, 15 years, 20, more than 25 years. The gestation period is very long. So you need to invest money for many decades. Even after that, there is no guarantee of success. That is what happens in research. So our corporates are not that much of risk takers. But on the other side, if you look at Nvidia, they have invested for many decades and they developed 2 nanometer chip. This is called investment or this is called innovation. Making an app, delivery app, 10-minute app, Blinkit or and this is called innovation. This is not innovation. This is just having some commission by providing a platform. Nvidia is innovation. Google is developing quantum computers. That is innovation. They have long-term vision. Their governments also have their long-term vision. If you look at their universities, the departments there, they basically invest them. They give them money for long period of time. This is how things work. So on one side we have I don't want to say that we have lack of vision, but we have lack of funds, and yes, there are a lot of other things also. Another thing is China. We have NSG group, nuclear supplier group. It's basically cartel of some countries. They have this technology of converting thorium into uranium, but India is not a member of that. China is blocking India's membership because if you're part of that group, you can have access to this technology from converting thorium into uranium. And if India has that access of technology, that machinery or advanced technology, we will be self-sufficient in this. But China is blocking India's efforts. China is saying India can use this technology to make nuclear weapons. So yes, there are a lot of other issues also. So I'll not be going into that much of detail. Otherwise, class can be extended in like 5 hours class. Okay. One more point. Right now, the things are going, very intense in Middle East. There is this, the Western countries, especially Israel and America, they are apprehensive that Iran is making nuclear weapons. But nuclear weapon cannot be made without enriching the uranium. So you must have heard this term in your newspapers, uranium enrichment. सुना है सबने ये enrichment? You must have heard this word. अगर आप न्यूज़पेपर पढ़ते होंगे तो you must be knowing it. Uranium enrichment. What is the meaning of uranium enrichment? Now, there are some news in newspaper that Iran has reached the stage of 90% enrichment of uranium. 90%. Although people are not sure, but yes, it may be a narrative from the Western media, but yes, that is there. France is giving 5% enrichment uranium to India. In Tarapur, France is giving from Jaitapur also and Tarapur also. In Maharashtra, we have a nuclear power plant. France is giving 2.5% to 3.5% enriched uranium for that. So France is giving us for Jaitapur, for Tarapur. Okay. So what is the meaning of this uranium enrichment? Uranium enrichment. So where is this uranium found? Uranium is found in nature. Yes. So if you talk about natural uranium, uranium is extracted from crust, earth crust, natural uranium. So we have uranium 235 and uranium 238. These are the two natural uraniums we have. But what about the isotope 233? What about it? It is created in lab. It is not in nature. अरे भाई अभी तो ऊपर हम लोगों ने किया था ना. It was converted from thorium. It was not natural. It was converted from thorium. Look, it is converted from thorium. It is not natural. But if you look at natural uranium, it's 235 and 238. What is the percentage? 235 is only 0.7% and 99.3% is uranium 238. Okay, 238. And in our nuclear weapon or power plants, we use uranium 235 in most of the cases. So we need uranium 235. We don't need uranium 238. So we need to increase the percentage of uranium 235 along with decrease the percentage of uranium 238. That is the meaning of enrichment. That is the meaning of enrichment. We where do we get it? Can you tell me few names of mines in India where we get uranium from? Jadugoda mines, Jharkhand, or Tillapillai in Andhra Pradesh. Okay, we have uranium reserves. But now we need to increase the percentage of this uranium 235. Now, uranium 238 is not fissile, it's fertile, right? So first you need to convert into it fissile, then it's a long process, technologically challenging, also complex process. One more step is added. So we don't prefer uranium 238, we prefer 235 because this is fissile, है ना? We must convert 238 into plutonium, then we can use plutonium. All obviously we have some plutonium based nuclear power plants also, but we prefer uranium 235 because uranium plutonium can be used to make nuclear weapons also. So there is a chance of nuclear proliferation, there is a chance of weaponization of this technology. So countries actually avoid uranium 238 for the civilian purpose. So we need 235. So what is the meaning of that enrichment? Enrichment simply means increasing the percentage of fissile isotope in mixture. Okay, in mixture. That is the date. Bas. So how to do that? Simply, how to increase the percentage? If we decrease the quantity of uranium 238 without changing the uranium 235, so obviously percentage of uranium 235 will automatically increase. Yes. Let me give an example. For the students who are not from math background, very simplistic example let me give you. So there is a boy, small boy, child. He has 10 toys. 10 toys. 2 toys are white, 8 toys are black. So what is the percentage of white? What is the percentage of white toys? You can say 2 by 10. Simply, not a problem. Yes, 20%. But if you want to increase the percentage of white, what will you do? You simply remove or take away, let's say, 5 black toys. Okay. Now, how many toys we have total? 5. Out of 5 toys, we have 2 white and 3 black left because we removed 5 black. What is the percentage of white? 2 by 5. Okay. 2 by 5. It's 40% now. Earlier it was 20%. So how did we increase the percentage? Just by removing the black ones. In the case of uranium 235, how we will increase the percentage? By removing uranium 238. As simple as that. Simple, very simple. So if you say 5% enrichment uranium, so what do you mean by that? Let's say you say 1000 gram of enrichment uranium, 5%. So what do you mean by that? It means you have 50 gram of uranium 235 and 950 gram of uranium 238. That is the meaning of it. That is the meaning of 5%. So 50 gram of 235, 950 gram of 238. If you say 90% of uranium enrichment. What does it mean? What does it mean? It simply means 900 gram of uranium 235 and 100 gram of uranium 238. Okay, this is how things work. So there is a question, sir, I'm finding it quite confusing. Okay, this subject is supposed to be difficult, especially for humanity students. I already told you that. Okay, in a way, history or polity can be difficult for the science background students. Hmm? So it's like playground where you need to play, doesn't matter from which background you are coming from. So I would suggest you can rewatch this section of the video again where you find your confusion, or you can revise your notes, come to the next class, ask me the doubt, I will clear the doubt. Okay, but this is extremely important, science and tech. I am trying to tell you again and again the importance of this section, S&T. There was this question a few years back or last to last year about James Webb telescope. Earlier we used to have a Hubble telescope, which was the largest one. Now we have a James Webb telescope. It is using new technology, more power. It can actually go deeper into the universe, closer to Big Bang. So it has more power to observe the universe. There was a question from James Webb. There was even question about James Webb that how it is better from the previous ones. It was a 15 marker question. If you don't know the technology, if you have not read this subject, how will you able to answer that 15 marks? It can be make or break. There was this question about the threat from asteroids. Asteroids like that solid bodies from our solar system visiting our earth, they can be quite dangerous. So there was this question in exam about the threat from asteroids. Even they were also talked about the technologies to deflect the asteroids. So that was a question in exam. So you can't say, sir, oh, I don't find this subject interesting or something. That's your loss. What I can do in my capacity, I can teach you here. I can clear your doubts again and again. Even two class later, you come to me after the class, sir, from the first class, I have this doubt. I will clear that. That's my duty. But you must revise. You need to go through the content which is given to you. That you must do. Okay, चलो आगे बढ़ते हैं. So that is the meaning of enrichment. Now, question might be in your mind, how to do this enrichment? What is the technology or what is the instrument? How? So we have an instrument, a machine, very technologically advanced machine, which is called centrifuge. Centrifuge. How does it work? Centrifuge is something like this, like kind of cylindrical kind of machine. Here we have a semi-permeable layer. So we have a semi-permeable membrane here. You know what is the meaning of semi-permeable membrane? It allows some, it blocks some. Semi-permeable, okay? It will allow some, it will block some. So what we do, we put natural uranium in this centrifuge. Natural uranium means 235, 238, which is found in nature. So what we do then? We rotate it extremely fast. And when we rotate it, uranium 238 is actually diffused through the semi-permeable membrane. And uranium 235 is vaporized because it is light in weight. Uranium 230 is heavy actually. It will vaporize, but 238 is going to be diffused in the next layer. So concentration or percentage of uranium 235 is increased while the percentage of 238 is decreased. But this is not going to happen only in the same machine. We have one more centrifuge attached to the first one. So this material is going to be transferred to the next one. Same process will happen. Then the next one, then the next one, then the next one. Okay. There can be hundreds or thousands of these centrifuges. They are lined up. They are connected. This process keeps on going and going and going and going. And this is how we enrich the uranium. Okay. It's very complex process. It's very complex. It can take years and years to enrich it. Years. Okay. So like America is saying that Iran has thousands of these centrifuges and they are enriching uranium on a very, very fast rate. Let me show you. These are the centrifuges. This is how they look like. Thousands of them are in the line. Okay. This is how things work. This is how things work. Getting my point? Yes. So, on the basis of enrichment, we have two types of uranium. On the basis of enrichment, we have two types of uranium. Uranium. Okay. One is called LEU. LEU. Light uranium enrichment. And one is HEU. Heavy uranium enrichment. LEU and HEU. Okay. You need to remember it. What is the difference? Let me tell you. So basically, it's criteria based on percentage. Percentage. LU means when an enrichment level is less than 20%. Less than 20%. I already told you about Jaitapur. Jaitapur, where France is giving us the reactor. France is giving us the enrichment uranium. 5% enriched uranium through 235. Okay, Jaitapur. Tarapur. Tarapur. 1962. India's first nuclear power plant. France is giving 2.5% to 3.5% nuclear enriched uranium to India. Okay, thanks to France. It is helping us. Helping us. Even UPSC also has asked questions from this section. Last year, 2023, there was a question in prelims. Question was of assertion and reasoning. What was the assertion? Assertion was this: to produce electricity, uranium should be enriched at least 60%. Easy peasy question. Extremely easy question. Array, you know, France is giving us 5%, 2.5%. Still, we are able to produce electricity from that. So 60% is extremely high. It can be produced on much lower level of 60%. Yes. So this assertion is removed. It is incorrect. So you can decline it. And if you can decline the assertion, it's extremely easy to find the answer. The problem with us is that we actually try to focus too much on facts. Too much on facts. And this is where we make like the mistake. You know, that there are one sort of aspirants who focus only on facts. They want to win 7 crore rupees in KBC. They can win, but they can't get selection in the exam. Because this is exam is not about facts. There can be another students. They can read anything and they become intellectuals. They can become intellectuals, but their name is not in the list. And then they can be students, aspirants who focus only on the exam. What is needed for the exam, they focus on that. So this question is extremely easy. But when this question was asked in exam last year, there was this whole, the students were very anxious that it was very difficult question. No, it was easy question. But provided you have read your syllabus, you have covered your subject in that particular way. Yes. There was another question in 2020. Question was, a statement was in the question was, a country with LEU can export to other countries. Answer is yes. France is giving us 2.5%, 3.5%, 5%. France is giving us. Okay. But there are terms and conditions, Ro. There are terms and conditions. France is giving us, but there are terms and conditions. First condition is that you can't enrich it further and you cannot use to make nuclear weapons from this imported enriched uranium. Okay. You can't do that. Like in Jaitapur, like Ratnagiri, Maharashtra, we get it from France, but we can't use it for the weapon purpose or the defense purpose. Another is that if you are getting enriched uranium from any country, there is this agency called IAEA. You might have heard it. Yes, it International Atomic Energy Agency under United Nations. It's a watchdog. It's a UN watchdog. वो नजर रखता है इसके थ्रू. It's a safeguard mechanism. There was another question from the safeguard mechanism as well. So if you basically these are some two major obligations if you import nuclear fuel, and India follows that. So there are frequent inspections of our civilian sites. Look, nuclear जो energy है, it can be used for two purpose: civilian purpose and the defense purpose. For defense purpose, there is no inspection from IEA, but for the civilian purpose, yes, there is an inspection, especially India is not a part of NSG group also. Okay. So this is about enrichment. So if there are some articles in the newspaper, if you read it about enrichment, so please you read it from that context. But I hope I have covered it in a decent way. Okay. And if you want to write it, you may write it. Okay. Do you want to have dictation right now? Okay. So let's take a break of 5 minutes and after the break I will give you a whole dictation from starting to end. ठीक है, it may take around half an hour, but okay, let's take a break for 5 minutes and we'll meet after the break. Okay, thank you.